Hello everyone, let us see about the double linked list in data structure. Firstly, let us see about the singly linked list. Singly linked list can be defined as a collection of objects called nodes that are randomly stored in the memory. A node contains two fields, data stored at the particular address and the pointer which contains the address of the next memory. Here we can see the node contains the address of the next node and the last node of the list contains the pointer to the null. So here we don't have any node after this, so it is null. So doubly linked list is similar to the singly linked list, but we have two links over here. It is the previous link and next link. So here we have the address of the next node and here we have the address of the previous node. And here we can see the codes of the two lists, a singly linked list. Struct node is nothing but the user defined data type, similar to int, float, etc. And here we declare the int data type, and struct node next is nothing but the address of the next node. And here it is similar to singly linked list, but the only line is added here as previous is nothing but the address of the previous node. Advantages and disadvantages of the doubly linked list. Reversing the doubly linked list is very easy and it can allocate or reallocate memory easily during its execution. As it in singly linked list, it is easiest data structure to implement. The transversal of the doubly linked list is bidirectional, which is not possible in single linked list. Deletion of the nodes is very easy compared to the singly linked list. A singly linked list deletion requires a pointer to the node and previous node and deleted, but in this doubly linked list, it requires only pointer which is to be deleted. So we can see we have temp here, and in temp we have 200. We have 200 over here and here, so deletion would be very easy in doubly linked list. Let us see disadvantages of the doubly linked list. It uses extra memory when compared to the array and singly linked list. Since elements in memory are stored randomly, therefore the elements are accessed sequentially, no direct access is allowed. So let us see creating a node in an empty list. So here we define the struct node as we already discussed, and it is a main function. And let's create a separate function for adding node in an empty list. Here we have two libraries over here, and we declared struct node, and this is the main function. And here we, with this piece of code, we can add new node. So implementation of the doubly linked list. So following insertion operations can be performed on doubly linked list. Those are insertion at beginning, insertion at end, and insertion in between the node. So let us see the insertion at beginning. So let us consider this is as an initial state of the node, and our target is to add this node in front of this node. And so the first thing we need to update is we need to use this piece of code to move the next part of the code to the head. After that, we need to update pre part of the code, so that this points of the other node finally will be updated to the head point. So this is the resultant list and this is the program. So here we have two libraries, and here we declared the struct node, and in the main function we added add to empty to add the empty node, and here we have add at beginning, so that we can pass the head as well as the data type, and this helps us to uh, give the particular pointer to the list. So let us execute this code in compiler and see what output we get. So here we type the code here. So here we have two libraries and we declared the struct node, and here we have head pointer and data, and here we created the memory for the new node, and here we assign the new nodes next to the current head, and we assign the data and new nodes prev null, and here we already have the items. We made the current head previous node as the new node, and here we change the head to the new node, and here we already know the display, so the code of display is written here, and here we declare the head 1, head 2, head 3, and here we're gonna display the uh, output we need. So let us run the code and see what output we get. So here we can see we got output for forward direction and backward direction. So let us see insertion at middle of the node. So let us suppose that we need to add a new node after position 2. So insert the node here. So we need a pointer to the second node of the list. So in order to do that, we use this piece of code, and we get the temp2 after temp. And now temp next is new p and temp2 is previous new p, and temp next is equals to new p and temp2 is prev new p. Now first we'll update the next point of the new pointer. So this is the resultant linked list, and here is the code. So this pointer has head, data and position, and we have 3 pointers over here, and here we have add to empty function in order to create a new node, and here we have the while position which we already know. Now we saw the insertion, and let us see deletion in doubly linked list. So we have similar to insertion, we have at beginning, at middle and at last. So deleting the first node, so our target is to delete this node. So in order to do that, we add this temp pointer over here, and head is equals to head to next. So this goes here, and head is equals to head to next. So and free temp. So we have to free this. So this got deleted as we saw, and see head previous null. So head previous is null. Here we got null. So let us see deleting the intermediate node. Our target is to delete this node. So we add the temp point over here, and this temp goes here with this help of piece of function, and temp2 is added over here, temp for previous of the temp, and now temp2 next is equals to temp next, and temp next is equals to temp prev2. So we make this as null, so this gets deleted. So this is the resultant linked list of the deletion of the middle node. So now deleting the last node, our target is to delete this last node. So in order to do that, we add the temp pointer over here, and with this piece of code, the temp goes to here, and temp2 is added to the previous of the temp, and now the temp becomes null, so this gets deleted. So this is the resultant linked list of our uh, deletion at the end. So let us execute this whole program in the compiler and see what output we get. So here is the code. Here we gave 2 libraries and we declared the struct node, and here we gave the pointers head and data, and here we created the memory for the new node, and here we assign the new nodes next as the current head, and assign the data and prev new nodes as the prev as null. And here if the list is already had the items, we need to make current and previous node as the new nodes, and here we change the head to the new node, and here we gave the insert last function, and this needs to be, there is no need of node present in the linked list at all. So here transfer till the last node, this while loop helps in it, and here we assign the last nodes to the next to new node, and here we assign the new nodes previous to the last node, and here we gave the display function, and here we gave the main function. Here we gave the address as we need to change the head, and here we gave the display head. So let us run and see what output we get. So here we got the output of forward direction and backward direction of insertion at n. Execute the all the deletion paths in the compiler and see what output we get. So here is the code. So here we gave the two libraries and we declared the struct node, and here we gave the in get length and struct node, and here we unsetted the head and data, and here we gave this fresh nodes data types, and if the linked list is already had at least one node, we get head previous as a fresh node, and fresh node will become the head. And here we gave the void delete friend function, and if the deletion at left side is empty, so here if the deletion list has only one node, so here if we move the next node and assign the head nodes to the previous null, and here we gave the delete end program, and here we gave the else transfers to the last node, and here we gave the current assign next last nodes as the next null, and if the head node itself needs to be deleted, we give this function, and here we give the function for the delete the first node as a loop, and here we transfer the nth node, and here we gave this as n minus 1 node, and here we gave this as n minus 1 node, and here we are assigning the n minus 1 node as next pointer to the n plus 1 node, and here we assign the n plus 1 nodes as the previous pointer to n minus 1 node, and here deleting nth node. So here we required it for delete nth node function. So here we use the while loop. So function to print the doubly linked list, this is the function. So here we give the insert, and here we give the delete third node, first node, and first node. So let us run and see what output we get. So here we got the outputs in forward direction and in backward direction. Lastly, see some real life examples of doubly linked lists. So many would have been wondering what would be the use of such data structure in real life world. So let us consider this situations. It is used in a music player which has next and previous button, and it is also used as undo and redo operations, and it is used in browser cache which allows you to move front and back between pages, is also good examples of doubly linked list, and it is used in LRU cache, and most recently used is also an examples of doubly linked list. A deck of card is a game, is a classical example of application of doubly linked list. It is also used to store state of game during play. So as already we saw some advantages and disadvantages at starting, let me tell that there is more advantages in doubly linked list than disadvantage. The big disadvantages is we have the memory here more, so it has 4 bytes, and here 4 bytes, and here 4 bytes, which gives 16 bytes for one node, whereas in single linked list we have only 8 bytes. As we know, there is only 2 nodes, so it contains 4 and 4, so only 8 bits is required. Here our presentation ends. Thank you.